Here's example 2 of using the law of sines. So solve triangle ABC, given angle A is 40 degrees, angle C is 22.5 degrees, and side B is 12. And we want to round to the nearest hundredth, which means 2 decimal places. So again, solving a triangle just means find all the missing angles and sides. So we could draw a picture right now, but before we draw a picture, it might be helpful to get all 3 angles. So in the previous video, when we did example 1, we said 2 angles is enough, and in general, it really is. But to get the most accurate picture, it's best to have 3. So then that way you can be sure, is the triangle acute or is it obtuse? And this is actually going to be an obtuse triangle, which might not jump out at you right away. And if it doesn't, that's totally fine. But what we can do is get the third angle, and then it'll be clear what type of triangle it is, and then we can draw a more accurate picture. So let's go ahead and do that. So we have 2 angles, and we know that because we're dealing with a triangle, if we add up all 3 angles, we get 180 degrees. So A plus B plus C equals 180 degrees. Angle A is 40 degrees. Angle B is the unknown, and angle C is 22.5 degrees. So 40 degrees plus 22.5 degrees is 62.5 degrees. Then we still have plus B equals 180 degrees. Subtract 62.5 degrees from both sides, and we get B equals 117.5 degrees. Okay, so this is an exact answer, so we don't have to round to the nearest hundredth in this case. There's no point in rounding because it's exact. So B is exactly equal to this. And now that we have this, we can draw a picture of the triangle that's going to be more accurate. So let's go ahead and do that. So I guess we'll do that maybe over here. There's a little more room. Well, that could have been a little better. Okay, so let's fix that. Oh, geez. Alright, that was a struggle. So, angle B is our obtuse angle, so this right here is angle B. And see, angle A is 40 degrees and angle C is 22.5 degrees, so this will be our angle A, because it's a little bit bigger the way we drew it, and this is angle C up here. Okay, so let's label first what we were given. We were given 22.5 degrees for angle C, 40 degrees for angle A, and we were given side little b, which is across from angle big B, which is 12. So we were given angle, angle, and the side in between them. So what we were given was an ASA triangle. So remember, we can use the law of sines for ASA triangles. So angle, side, angle. Okay, ASA, angle, side, angle. So the law of sines will work for an ASA triangle. Okay. So now, what did we just find? We just found that B is 117.5 degrees, so we can label that. So we don't really have to, but why not? Now we need to find little a and little c. And how are we going to do that? Well, exactly like we did with example 1, we're just going to use the law of sines. Okay, so what we're going to do now is say little a over sine of capital A equals little b over sine of capital B. Okay. So multiply both sides by sine of A, and then we get little a equals b over sine B times sine A. Now we know little b, we know big B, we already found that, and we know capital A. So let's just toss all this stuff into here, and then we get A equals little b is 12, and then capital B is 117.5, so sine of 117.5 degrees. And then multiply by sine of 40 degrees, because A is 40 degrees. Okay. So when we toss that into a calculator, what do we get? We're going to get A is approximately, it's going to have to be an approximation here. So let's go ahead and see what we get. So we'll turn on our calculator, make sure that we're in the degree mode. We'll zoom in here. Okay, so make sure that we are in degree mode, and we are. That's great. It's DEG, deg for degree. And then what we want to do is 12 divided by sine of 117.5, oops, and then multiply by sine of 40. and we get approximately 8.6960, which rounded to the nearest hundredth is about 8.70. So 8.70 approximately is the answer for this. So A is about 8.70. Now, how do we get little c? Okay, we have little a, now we have to get little c. We get little c exactly the same way. So we can just say, let's use a different color since we're kind of cramped in here now. We can just say little c over sine of big C equals little b over sine of big B. Now, according to the law of sines, we could do c over sine c equals a over sine a, but little a, this is an approximation, and like we always say, we do not want to use an approximation to get some other value, because the other value might be inaccurate, because here we round it to so many decimal places. And it's best to avoid using the approximation if you can. Okay. Anyway, c over sine c equals b over sine b, so multiply both sides by sine c, and we get little c equals b over sine b times sine c. Okay. And we know little b, big B, and big C, so we'll just toss them into here. And then we're going to get little c equals 12 over sine of 117.5 degrees. And then we're multiplying by the sine of c, and c is 22.5 degrees. Really running everything together here. So now when we toss that into the calculator, we get c is approximately, let's see. So go back to our calculator. Now we want to do 12 over sine of 117.5 degrees times the sine of 22.5 degrees. So we'll zoom in here. 12 over sine of 117.5, we already have that. Now we have to multiply by the sine of 22.5, so that's degrees, so that's all we had to change there. And that is approximately 5.18 if we round out to 2 decimals. About 5.18. So we'll zoom out here. C is approximately 5.18. And we weren't given any units, so we could just write the word units here and here, but it doesn't really matter. So that's example 2 with the law of sines, and here are the answers again.